Hello and welcome to Mr. Connally's Math. We've got graphing linear inequalities today. Before we go any further though, don't forget to like this video, subscribe to the channel, and hit that bell to receive notifications about future videos. Guidelines for using this video effectively are: watch and listen to the video. The sound should be on. Do not skip ahead. Do not just skip mindlessly copy the work. Pause the video when you need time to write or think. Put a question mark next to problems you don't understand. Rewatch and listen to the video as needed. And ask questions in class or in the comments below. Key concept for today: how do you graph linear inequalities? Okay, well, we've got 3 steps to do that. First, we want to graph the line, test the points, and then shade the solutions. Remember, inequalities have more than one answer, so there's going to be more than one dot on our graph. So we're going to use something called the shading technique to show all the possible answers. Okay, so let's start with the basics. Let's say we have a horizontal line. Y is less than or equal to -1. We want to use our ideas for graphs, which are less than or greater than have a dotted line, less than or equal to or greater than or equal to have a solid line. Just like when you graph them on a number line for just one equation or one variable like x, you got to fill in the dot if the answer is also the number on the boundary line, or if it's just less than or greater than, you leave it open. It's the same idea. You use a dotted line or a solid line. Okay, so once we have the solutions, we know that all the answers are going to be where y is less than or equal to -1. So it's -1 right here. Right here is -2. That is less than -1. And then also -3. And it can go all the way down. But then it also has these points out here are all less, where y values are less than -1. So we actually have to shade in the entire area like this. You'd actually take your pencil and shade like that. Okay? So that's how you would show all the answers in that case. Now let's look at a vertical line. Okay, what if x is greater than 6? It doesn't include 6, but it's greater than that. To show that x is not a possible answer, we use this dotted line, that idea right there. So whenever you use less than or greater than, use a dotted line in these equations. Okay, so what's greater than 6? Well, that would be 7, 8, okay, and 9, 10, on and on and on. So everything to the right of this line, basically, because all of these points are also x values that are greater than 6. So we would shade everything to the right of that boundary line, everything that's greater. Okay, now what if it's a diagonal line though? Let's say I have y is greater than x plus 3. Well, I draw the line like I normally would. I pretend it's y equals x plus 3. I graph it on there. And then in this case, it's greater than, so we're going to have a dotted line again. But this is a little trick to help you. If it's less than or less than or equal to, you want to shade under the line or below it. Okay, in this case, that would be down here. But it doesn't ask us to do that. It asks us to do greater than. So that means that we're going to do above the line. So that means all the answers would be up here. So we would shade it in like this. Okay, so that was how you would show the answer. All right, so remember, graph the line, test the points, and then shade the solutions. Example 1, graphing vertical boundaries. We want to graph the inequality x is greater than -1. Okay, so I normally would think of this as x equals -1. What would that look like? It's a line where all the x's equal -1. So that would be right here, and right here, and right here, and right here, and right here. Now this is saying x is not -1, but it's greater than it. So that means all the answers to the right of it are going to be it. So let's go ahead and, because it's greater than, I'm going to go ahead and put graph the line, and it's going to be a dotted line. Okay, because it's greater than. It's not greater than or equal to. So that shows me that these answers are not possible, but they have to be greater than. So I'm going to test the points. We know, let's just choose 2 right here. X equals 2. We substitute that in. Is 2 greater than -1? And the answer is true. So that means that this is a possible answer. Now, what if I did -2? What if I said x is greater than -1 and I chose -2? Okay, I substitute that point in. Is -2 greater than -1? No, that's false. So that means this is not a possible answer. So again, all my answers are going to be to the right of the dotted line. So I'd shade it in like this. And that's how I test my points and then shade the solution. All right, go ahead and finish that one up. You ready? Let's move on to the next one. Now, what if I had y is less than or equal to 4? We're going to look at a horizontal boundary this time. So 4 would be 1, 2, 3, 4. Here's a y value of 4. Also, here is 1, here's 1, here's 1. Those are all y values where y equals 4. So that means we would have a solid line that goes through here. Now remember, you got to check to see if you're going to have a solid line or not. You would look at this right here. Because it's less than or equal to, it's going to be a solid line as opposed to a dotted line. So we'll go ahead and graph the line, test the points now. We're looking for where does y is less than or equal to 4. Okay, so 4 is a possibility. What about 3, where y equals 3? So we'll say 3, is it less than or equal to 4? 3 is less than 4, so that's true. So that's a possible answer. Now what about 5? Is 5 less than or equal to 4? We'll substitute that point in. No, 5 is not. This is false. Since it's false, that's not a possible answer. So we've concluded and tested the points to find that everything should be shaded under the red line. Okay, go ahead and finish that up. All right, let's move on to the next one. Now, how do we graph this solution, a diagonal line? All right, so first we want to make sure that we graph the line as usual. 5x minus 4y is less than 20. This is in standard form, so let's put it in slope-intercept form so it's much easier to use. We'll move the x over. 20 can't be subtracted by 5x because they are not like terms. So we've got negative 4y is less than negative 5x plus 20. And now I divide everything by negative 4. And I get y. Now I divided by a negative number. Remember, we've got to reverse the symbol. It's actually going to be, instead of less than, it changes to greater than, because my slope went from being a negative number to now it's going to be a positive 5/4 and then minus 5. Okay, so y is greater than 5/4 x minus 5. This has a slope of 5/4 and a y-intercept of negative 5. So we'll start at the y-intercept and use the slope to guide our way. So negative 5, 1, 2, 3, 4, 5 right here. There's our y-intercept. And now we go up 5 and right 4. So 1, 2, 3, 4, 5. And 1, 2, 3, 4. There's my 2 dots. I can draw now a straight line through them. Now remember, it says greater than 5/4 x minus 5. Since it says greater than, that means that we have a dotted line. Okay, now remember our trick. If it's greater than, the shading goes above, and if it's less than, it goes below. Let's test a point to make sure. Now, if I'm looking at a number above this dotted line, I'm going to go ahead and choose this one, 0, 0. Now, why would I do that? Well, because it's easy to substitute and check to see if it's true or false. So let's put in a 0 for x and a 0 for y. We'll say 0 minus 0 is less than 20. And is 0 less than 20? Is this true? Yes, it is smaller than 20, so that means this is true. So this is a possible answer. That must mean everything else around it is also a possible answer as long as it's above the line. Okay, so far this is working. Now I want to choose a number that's below the line. I always like to use the x-axis. So right here, let's see, this number right here is 5, 0. And I'm going to go ahead and substitute that into the original inequality and then see if it's true or not. So this will be 5 and this will be 0. 25 minus 0, is this less than 20? 25 is less than 20. No, it is not. This is not true. This is false. Okay, because that is false, that means that is not a possible answer. We've concluded that our little trick is correct. If it has a greater than symbol, then that means that we're going to shade above the line, which in this case is the top left. So like this, and there you have it. Go ahead and finish that problem up. You done? Let's move on. Okay, summary. How do you graph linear inequalities? First step, we graph the line. We test the points on the above or below the line, or the left and the right, depending on the line. And then we shade the solutions. Remember, if you're using greater than or less than, you have a dotted line. And if it's less than or equal to or greater than or equal to, use a solid line to make your line. Solutions are either below the line if it's less than or greater than, less than or equal to, and if it's greater than or equal to, the solution set is above the line. Okay, you can always test the points to make sure that they work if you can't remember. Okay, all right, keep working hard. I appreciate all the things that you're doing in class and asking good questions and helping each other out. That's all what a great math classroom looks like. Let's continue to do that. If you need anything, let me know. I'm here to help. Right now, I just want to tell you.
Excellent work on completing this tutorial. If you like this video, be sure to give it a big thumbs up and subscribe to Mr. Connally's Math and Mr. Connally's High School Math channel to get updates on future videos. Thanks for watching.
MrConnally.com